then you are going to uh, sign in. Now, if you don't know your sign-in stuff, then you're going to have to uh, get that. How do you get somebody who knows what they're doing? How do you get that stuff? Do you, besides just knowing it, where do you get it? Can you get it? Your parents know it, or the counselors know it? How do you get it? Okay, so you have to reset it and have your new password sent to you and all that stuff. Do at least. Okay. So at some point then you're going to need to figure out your sign-in stuff so you can get signed in. If you don't know your sign-in stuff, that should be your homework tonight. Make sure you get that sign-up stuff so you can get signed in and call it forth. All right? Assuming those of you who are successful were able to do that, would you then go to join a course or exam button? You see that somewhere. Okay, join a course or exam. When you hit join a course or exam, you need to submit the code for that class that you're going to join. Here's our code. I believe these are all caps. XMZDX7. XMZDX7. Hopefully, that will, when you hit submit, you will get verification of the correct course. It'll come up with, I don't know if it says my name or if it says Devlin. What does it say? It says this class? Devlin. Okay, so as long as it says, does it say AB? Hopefully not BC. Yeah. I think I gave you the right code, my BC code. Okay, yay! Not important. All right, so hopefully that went well. Then what do you do after that? Do you have to fill out the what's this stuff? You have to do the registration information? Okay, so you have a little registration information. If this is the first time you've enrolled in an AP course in My AP, you'll have to do that if you've already done this for another class. And it sounds like you've already done that. That's partially why I'm doing it later, because I feel like then some other teacher had you do courses. Yes. 80235 is our zip code.
Okay, so where do I just signed in, so where do I go from here? Why is the code not recognized? Did it change the code?
Ah, jeez. All right. Hopefully you're enrolled in AP Calculus. I guess that's news to you. You have, to me, been enrolled for 12 months. Hey. All right. Are we cool? All right. Having a hard time figuring out if you're really still working or now you just said you were done 10 minutes ago and now you're in this.
I'm done.
I got you.
Oh,
Okay. So, I'm gonna move on. It feels like we're cool. Blackburn, how we doing, man?
almost done.
We're good? All right, good. It's important. I want to know what you have time to do. Alex, you're here later. You good? You good? Okay. Okay. So, this is not something you have in your notes. This is just a slide, but this is test review. All right. So here's the deal. While you might, if you want, you can take out some paper to write these down. While you do this, I need to explain my strategy in terms of tests and test reviews and such. If I fail to give you a huge test review with sample problems and all that stuff, it's not because on this test I'm lazy on you or I had a hot date last night or something like that. I had other stuff to do. It's that I want to strike a balance between rewarding a student that always does the right thing, that they're doing the homework every day, they're doing their best, they're giving me their best, and I want to help them brush up a little, get ready for the test. I want to help that student. But you have to understand, and that might be you, you might be, why are you such a jerk, I want to review. You have to understand that I also have a student in the class, or a couple students in the class, that take more of a, yeah, you know what, he's gonna give me a review, so I don't really have to do the homework that much, because I can just smoke the review and do well on the test. Well, I want that student to fail, so that they can grow and learn that they're an idiot, and they get better. A review needs to strike a balance between rewarding the students that are doing things the right way and helping them push them over the top, and also not reinforcing that I'm going to blow out the homework, do a crappy job, but still be okay. All right. So in that case, in this case, then I'm just going to give you a quick rundown of a few things I think you might want to consider before the test. But for the most part, the homeworks have been your practice test. You should be ready. All right. So a few things. My board has been terrible today, so hopefully it'll go well. The test is through set 39, which is area under rectangles, but it doesn't include the higher level stuff here, right? So you're not going to be interpreting the area under a curve and what it means. You're not going to be doing unequal subdivisions. I also don't care if you can do lower and upper right now. That's not a big idea of calculus. I know in Saxon he's been given a lot of homework problems on lower and upper. It's way more, like 90% of the time more, that you do low, left, right, mid. Those are the big ones. Okay, so test tomorrow will be equal subdivisions, left, right, and midpoint, and you need to be able to work with either an equation or a table. Okay, do you feel confident on that, or would you like to do a warm-up to practice that? All right, so then let's pause here real quick and go to number 7. 7 is finding, now this 7 is actually a little harder than I would expect you to be able to do tomorrow. Estimate the area under y equal e to the x on -1 to 1 using 5 left rectangles. Okay, it is calculator active. Give me an answer to 3 decimal places. I will also try and communicate to you what I would have points for, what kind of work I. Yeah, 5's kind of funky, and I wouldn't go that difficult tomorrow. It'll be pretty straightforward tomorrow. I don't even have 23. Oh, yeah, I do. doing? Are we about at an answer?
Not quite.
Yeah, I like that. All right. So this is my thought process. You first need to find delta x. In your own words, how do you find delta x? How do you find the bases of each?
So I do B minus A.
Okay.
All over
Rectangles?
rectangle.
Okay, yes. All right, so depends on if you're more of a formulaic person, if your memory handles that well, then B minus A represents the right end minus the left end, and N represents the number of rectangles. That is a pretty common formula. In plain old English, it's the total region divided by how many rectangles, right? You with me? Total region divided by number of rectangles. Okay, so in this case, what's delta x? 2/5, all right? For when I say sketch this, really, I don't, the curve is fine, and for upper and lower, I kind of do need to see the curve. But for left, right, and midpoint, all I really need is the horizontal, and I don't even do the whole region. I just start at -1, and then I go delta from here. So if -1 is my first edge, and I go 2/5 each time, then what's my next point? -3/5, add -2/5 to get -1/5, add 2/5 to get 1/5, add 2/5 to get 3/5, and add 2/5 to get 1. All right. The curve, if you like, is in here, and that's great. But again, I don't really, for left and right, I don't really even need to see it, quite frankly. All right. When you go to set up the area, you should always. So this is nice background, but what I absolutely have to see is a factored out delta x name. So what is delta x? 2/5, and I need to see at what x values you made your heights. So if we're using left, this communicates to me whether you know left, right, or midpoint, right? If we're using left, then we start by using f at -1 and -3/5. Should I have all 6 of those numbers? No, I should have 5 because there are 5 heights, 5 rectangles, all right? So I'm not going to use all of those. It'll be that, yeah? And so last but not least, let's talk about entering this into your calculator, all right? Is e to the x, would it be hard to type in 2/5 parentheses e to the -1 plus e to the -3/5 plus e to the -1/5? Would that be hard to type in? It wouldn't be too bad because it's pretty much e to the blank is a pretty clean function to type in. Are you with me? But if I said, hey, find the area under e to the sine of x cubed plus x plus 5, are you going to want to type in that with -1 in it every time, and that with -1? So what would you do? Yeah, you'd store it to the graph and call up f1 at this plus f2, f1 at that, right? You with me? All right, so what'd you get there? 912. All right, do we all agree? Okay, going back to the review. Integral of a sum, that's been going pretty well. The only things I can say are a few of the common classic mistakes that when you integrate 1/x, it is
Absolute value.
absolute value of x. Don't forget the plus c, senor. Also, this guy is not to be ignored. That tells you the variable of integration, which is important, especially when you're integrating a constant. Is this 3x?
3u.
It's 3u. Use
Plus
that
c.
to gauge what the variable was. Last but not least, don't forget the importance of a rewrite step. If you have something that is not clean power, then you should start by rewriting it so that it can be easier to integrate And what is the power rule for antiderivatives? Add 1, divide by the new power, yeah? Alright. The chain rule, when do you use it? Use when?
Function and a function.
When you have a function within a function, I beg you, read carefully for parentheses. I will give you an example. If I said what is the cosine of x squared plus 1, and g is the cosine of x times x squared plus 1, then f's derivative would be found via chain rule. But g's derivative would be found via product rule. Okay, that one little difference obviously makes a big difference in how you approach the derivative. Are you with me?
Yeah.
Okay, differentiability. This has been a while since we've gone back to this. This is definitely something I want to review. There are 3 reasons a derivative doesn't exist. A derivative doesn't exist if there is
Discontinuity.
a discontinuity, a hole, a vertical asymptote, a jump. What else? Sharp turn. That's an abrupt change in slope at a point, or not asymptote, vertical tangent. What's wrong with vertical tangent? The rise over run is undefined. That's division by 0. That's why the derivative is no good there. You with me? Critical numbers. They are places, x's in the domain of a function where the derivative is 0 or undefined. Would you go to number 25, please, for practice on that? Are you ready? Okay. How many critical numbers did you get? 2. Okay, so first thing I look for is, did you find the domain? Would you agree that for a root x squared minus 4 must be non-negative or greater than or equal to 0? That
Yes.
implies x must be either
0.
greater than or equal to 2 or less than or equal to negative 2. In order for the square of the number to overcome the subtracting 4. Are we good? Now you need to take the derivative. The derivative would involve the chain rule. The derivative is 1/2 x squared minus 4 to the negative 1/2 times 2x. At that point, I would pause and say, did they find the derivative correctly? That would be 2 points. Did you find the derivative by chain rule? Well. Yes?
Yeah.
All right. Now, if it just said, hey, take the derivative, then I wouldn't care if it was ugly. I'd be done. But if they say find the critical numbers, the cleanup then is kind of unnecessary. So I'm going to rewrite this as 2 root x squared minus 4 with a 2x, drop the 2, and maybe go x over root x squared minus 4 for a clean form. Do you agree with that clean form?
Yep.
All right, cool. So now I want to find this as 0 or undefined. The derivative is 0 if the top is 0 or the numerator is 0. This happens at x equal 0, but is that a critical number? No, it's outside of the domain. So that, although a good possibility, is not in the domain. That's not a point of the graph, so it's not a critical number. All right? Y prime is undefined if the denominator is 0. That means x squared minus 4 equals 0, which happens at positive or negative 2. Are those in the domain?
Yes.
They are. There are two critical numbers, x of 2 and x of negative 2. Graphically, what does this graph look like? Y squared equals x squared minus 4, right? That means 4 equals x squared minus y squared. Is this circle or hyperbola? Sideways or vertical? Top half, bottom half?
Top half.
Looks like that. Does it make sense that 2 and negative 2 are critical? Yeah, they're kind of important. All right. Going back to the notes or the test ideas, and then we'll be good. Other things I intend to put on the test: implicit differentiation, including that AP practice. Did I give you that back?
Yeah,
I have a couple extras here, so I have people that it was yellow or something, right? That free response. All right. Derivative technique, applications of derivative, limits of derivatives, and instrumentation. I intend to look at what the questions have been in your homework a lot, and maybe those will be reflected in your test. Just reminding you of big ideas of calculus. I'll do this all year long, all right? Limit big ideas. The first thing you remember, it's about the approach, not necessarily the act. Although sometimes they're the same, right? You always try direct sum first. So for example, if I say the limit as x goes to 2 of x minus 2 over x plus 2, first thing you try and say is, can I put 2 in?
Yes.
And you get 0, okay? In this case, then, you're just using the fact that the at and the approach are the same. We're all good. Sometimes you get problems. If you had something like this, what is it? Okay, it's undefined, or DNE. The limit does not exist because you have a 0 in the denominator. Asymptotically speaking, there's a asymptote there. What about if you have top and bottom zeros? Does that mean DNE? No. If you get 0 over 0, does that mean quit?
It means do more.
It means do more. 0 over 0 means do more. In that case, you can factor out and cancel and then get the limit, right? Remember, 0 over 0 often means derivative. Now, sometimes that's just slap you in the face obvious, like when you see an H. If you see an H, think, oh, geez, I bet that's derivative. And that would mean derivative of sine. And you would then say, is it general derivative or at a point? General. And then, I got to tell you, the most common mistake when people do this, if they make a mistake, is then they say that, there you go. Yeah, exactly. That's what I say. Oh, you did, yes, you did great in saying it's the derivative of sine. But you know what? I actually want you to take the derivative. So the answer is not, hey, it's derivative of sine, I'm done. The answer is cosine. That's the answer, all right? After you've recognized it's the derivative, now take the derivative. Sometimes it's less obvious. Go back to this. Now we said isn't that a hey, factor and cancel? And truthfully, you can factor and cancel. But this is also the alternate definition of the derivative of what function? X squared at what point? At 2. The derivative of x squared is 2x. At 2 is 4. All right, so sometimes you can help yourself by doing that. Derivative ideas. This, I'm talking the big ideas of calculus. If f prime is positive, then f is increasing. If f prime is negative, then f is decreasing. And if f prime is 0, then f is flat or horizontal tangent. That could be used in so many ways. It could be graphical. I could use it to find a maximum by the first derivative test. Lots of different ideas there for extreme. All right. And then last but not least, this wasn't an actual lesson. It's just kind of interspersed throughout calculus. But let's just remember the big ideas. I'm talking position, velocity, and acceleration. Now, position could be horizontal. It could be vertical as a function of time. These are a function of time. Or it could just be some basic P of t or S of t. They're all pretty common. You with me? Okay. Velocity is change in position over time, yeah?
Yep.
So let's look at this two ways. On an interval, average velocity is change in position over change in time on an interval of time. 2, think secant slope or slope over a region. You with me? But in a calculus sense, instantaneous velocity, instead of delta x over delta t, we think dx dt, or velocity is the derivative of position. Okay? Okay. Acceleration is the change in velocity. So average acceleration is delta v over delta t over an interval, but instantaneous acceleration is instantaneous dv over dt, or acceleration is the derivative of velocity. It's also the second derivative of position, okay? You need to be able to use those in conjunction with thinking. So, if I said, if I gave you position and I said, find when it's at rest, you would do what?
Or f equals 0?
F prime?
No, f 0.
F?
X.
X? X prime, there you go. Velocity, you would make the calculus connection. I'm finding velocity, which is position's derivative, equals 0. Cha-cha-cha. What if I said, find when velocity is increasing?
Where f prime is positive.
Okay, velocity is increasing if velocity's, this is a big idea of calculus. Something is increasing if its derivative is positive. So if I want to know where velocity is increasing, then I need to know where velocity's derivative is positive, which means find when
Acceleration.
And so if I was given position, I'd have to take second derivative to get acceleration, do a sign test, and then answer the question. You with me? A lot of thinking there. Each problem is different. You have to think on your feet. All right. Those to me are the big ideas that you'll see tomorrow.
I have a question.
Yes.
So one of the things is like an effect, like a little like sentence there with like summation notation.
Yep.
Is that
So it could be something like as easy as this. Let's say e to the x. Let's go a little cleaner than that. let's go something like 2I from I equal 1 to 3. That should be doable with or without a calculator. You've also seen something like, hey, I'm telling you that the sum of squares can be found by this formula. Find the sum here. Or verify the formula works. All those summation ideas are not just, I just want to make sure your pre-calculus is still good. Those are ideas I need you to know for set 42. So those will be in there. So you feel good there?
Yeah.
All right, pretty much just pull one from the homework, really. Okay, that is for the test. Are we feeling okay? Okay, the notes. So, quotient rule. You know how to take the derivative of a single term with a power. You know how to take the derivative of lots of different transcendental or wacky functions, e, sine, cosine, log. Don't know any of the rest, but you can do the rest for today. You can do a product, you can do a chain, you can do implicit differentiation. In other words, you have lots of techniques, but you're still missing some derivative techniques. One is how you take the derivative of a quotient. Like in a second, you'll take the derivative of something like that using the quotient rule. First, though, we got to pay our dues and get the quotient rule. Now, this actually can be, I would normally say just go this, have you do it yourself. But I'm going to, in the interest of time, show you where it's coming from. So the idea is, if h of x is some generic quotient, how do you find the derivative? Now that's the quotient rule, but you can actually do this with some of the skills you already have. If you let h of x equal f of x times g of x to the negative first. Now that's, in this case, that's a power, not the inverse. And remember, sometimes that notation means inverse, but in this case I'm saying to the negative first power. Are you with me? All right, now if I then take the derivative on this, I'm going to need two rules. I'm going to need the product rule and the chain rule. So by product rule, first stays the same. And when I say derivative of the second, that's a function within a function. So by chain rule, what's the derivative of the second? -1 g of x to the negative 2 times g prime of x. That's first times the derivative of the second, plus second g to the negative first times the derivative of the first prime. There's the product rule, yay? Are you with me? All right, now you can imagine that would be just terrible to try and memorize the chain rule or the quotient rule for that. So let's clean it up. If I clean this up, then I would say this is something like negative f of x g prime of x over g of x all squared for the first cleaned up. And the next one, I'm going to call it f prime over g of x to the first, or just g of x. You see what I did there. All right, a little more cleanup. Common denominator would be g squared. The first then would have no changes because it already had a denominator of g squared. So it stays negative f g prime. But the second one, you only had a single g, you need g squared, so you had to multiply it by g, right? All right, now that is the quotient rule. Let's write it in the box. I'm going to write it in the box without the arguments. I'm also going to write this in a little different order. It's pretty weird to see a negative first term, so instead we're going to switch the order here, and would you write this in the box? G f prime. I didn't give you a lot of room, so I'm going to leave out the arguments, okay? So I'm going to leave out the of x's, okay? gf prime minus fg prime over d squared. Now that seems like you guys have pretty darn good power to memorize, but this is actually not that hard to come up with because there's a really easy mnemonic that never fails you. Ms. Cannon says this a little different than I do, okay? But it goes something like this. When you take the derivative of a quotient, it's low, which is the lower function, d high, which is the derivative of the upper function, minus high, the upper function f, d low, the derivative of the bottom function, over the square of what's below. So please say it with me, right? Low d high minus high d low over the square of what's below. Okay, I appreciate you saying it with me. You're not too cool to say it. Cool people get these wrong.
Nice.
All right, so using that idea here and saying the mnemonic as I go, right? So low, what's low?
X squared minus 1.
D high,
3 e to the x.
okay, minus high,
3 e to the x.
D low,
2x.
2x, over the square of what's below means put it in parentheses and a square outside and boom, you're done. That's it. Okay? So easy. So this one, I don't think you have this third one, but you do have the first two. Would you do those two on your own? By it's low, not low. As always, don't forget to give a label to it. That's the derivative you count. You should have that prime equals on the side. Did you get the first one? Sine of x times -1 minus 2 minus x times cosine of x over sine squared. You good?
Yep.
Okay, try the next one. Next one's got a little bit of chain rule in it, but I think you can handle it. Are we ready? Okay. Okay. So the low is cool. Obviously, that just takes vision. D high. So what's the derivative of the upper? Because you have a function within a function, you got to use the chain rule, right? What's the outer function? Cosine. What's the inner function?
2x.
Okay, so what's the derivative of the outer with the inside the same?
Negative 2 sine.
2x, and then what's the derivative of the inside? 2. So you can imagine a multiple choice maybe having -4 there. Right? All right. Although I don't care if you clean it up. So low d high we're cool minus high d low. What's the derivative of the cube root of x? Okay. Over the square of what's below is, you could call that x to the 2/3, you can write it that way, whatever you want. You with me?
Yep.
Okay. in the interest of time, I need to jump around a little bit. This is really a second idea that I'm not gonna have time, so the two implicit, I am gonna come back to the notes, so don't put them away yet, but the two implicit at the bottom of those notes, skip those, we'll come back to those. But I need you to get to the homework first, please, before I forget. And on the homework, would you circle 4 and 21? Saying leave them till Friday. I'm not going to teach that part of the lesson, so you won't be able to do those after homework. Leave 4 and 21 till Friday. Is that clear? Okay, 4 and 21 till Friday. Now head to the back of the notes. I'll come back to this on Friday. Go to the back of the notes. So, now that you have this quotient rule, you can use it in conjunction with the application ideas, like when is the function increasing or extrema and all that stuff. So in this case, it says find the critical numbers and determine what you got going on there extrema-wise using the first derivative test. So critical numbers, what do we typically do? The domain is x cannot be domain. 1/4, okay? It's important that you do that domain first, because if that point doesn't exist in the function, it probably won't exist on the derivative, so you don't want to think that asymptote is actually something interesting. It's just an asymptote. All right, now let's find the derivative. The derivative will require the quotient rule. Try the derivative by the quotient rule.
All right.
Okay, so a lot of cleanup to be had here. I heard. I hate factoring. It does factor well. I just don't. I mean, 2x squared is prime. I mean, it's not like there's a lot of choices here. 2x and x. Oh, you guys probably do that AC stuff, huh?
AC stuff.
I wouldn't do that.
No, I
AC.
factored out.
Okay, I would just do this by just kind of thinking it through. 2x squared only factors one way. 2x and x, 1 only factors one way, 1 and 1. The only issue is the signs. To get a negative 1x in the middle, it would have to be OI. It would have to be negative 2x positive 1x. So the OI signs would have to be there. Are you with me?
Yeah, definitely.
Okay, so finding our critical numbers. F prime is 0 if x equals
1/4. Oh, wait, no.
1 and
Negative 1/2.
negative 1/2. Okay? F prime is undefined if x is
It's
1/4, yeah? Now that's not a critical number because that's not in the domain. You with me? Are you with me? Okay. Now, when you go to, write yourself a note here. This is kind of high level stuff. When you go to make a sign chart, use this in your sign chart, because although it is a critical number that doesn't actually give you stuff, it can be a place where your signs change. So you have to include it in your sign chart for the derivatives. So your interesting points are What's the least? Negative 1/2 or negative 1/4?
Negative 1/2.
Negative 1/2, then negative 1/4, then 1.
Wait, it's positive.
Yeah.
Oh, it was positive 1/4. Thank you. Positive 1/4. Thank you. Negative 1/2, 1/4, 1. Are you tracking?
Yep.
Okay. We're sign testing the old derivative now, and this is pretty gross. So, give me a region or a number left of negative 1/2.
Negative million.
Negative 1 million. Positive, negative, negative, and so the bottom is always positive. So really, I just need to focus on these. Wouldn't they be negative, negative? And therefore, in that region, the derivative is positive. When I go over negative 1/2, like maybe it's 0, I got your positive, negative in the top. The bottom is always positive because it's squared. So that region is negative. The function is decreasing. Increasing, decreasing. F is from 1/4 to 1, maybe whatever, 2 1/2. I got positive, positive, positive. That is positive, positive. What am I doing? That's not positive. That's still negative. Sorry. So that's still decreasing. And then after 1, then I've got positive, positive, positive. That's positive. So now extrema. Okay. F has a max at negative 1/2 because goes positive to negative. And F has, what's going on at negative at 1/4?
It's crossing.
That's a vertical asymptote. Nothing's going on at a 1/4. It's not a min or a max. It's an asymptote there, so keep that in mind. Okay? So that's nothing. What about at 1?
There's
There's a min at x equal 1 because f prime goes
negative.
positive. Alright? I'm going to have to finish the rest of the notes on Friday, which is fine. Questions? What questions? If you have a couple questions on set 41, hit me. 12, did you say? Okay. 12, 22. It is possible. It does happen once in a while. That's going to be endpoints. Did I change $12 at the like in the book? Oh. All right. Okay. So F is 1 plus x sine of x plus log of x cosine of x, I believe. 10. Okay, A is graph F. Boom. 1 plus x sine of x. Did anybody get an error message when they tried to graph this?
Good morning, Devlin Jaguars. Please rise for the pledge of allegiance. Please begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Tonight is the bonfire. The festivities start at 5 p.m. The bonfire will be lit between 7 and 7:15 p.m. Tomorrow is Dad's Point. Tomorrow is Throwback Thursday. Tuesday, Becky or Past Era and Recipe They're tired. Today is also National Custodian Appreciation Day. We are fortunate to have a great Thank you, Ron.
Thank you, Ron.
We work tirelessly to make sure our school is taken care of and our facilities remain pristine. Please make an effort to say thank you to our custodians as we celebrate their excellence on Custodian Appreciation Day. Have you ever wanted to watch 8 people all fall in love and mysterious forest? Come to the DHS Fall Play Shakespeare as You Like It. Buy the tickets at lunch or at the door for $10. But students get a $5 discount with their student ID. Juniors and seniors, if you missed the opportunity for college fairs at the Lakewood High School College Fair, it's tonight from 6:30 to 8 p.m. Last chance for college fairs this season will be on Saturday, October 5th at Mountain Vista High School in Highland Ranch. It is best to pre-register.
Okay.
Counseling college visits at 12:30 p.m. St. Benedict and St. John University from Collegeville, Minnesota at 1:30 p.m. Trinity University from San Antonio, Texas, and during 7th hour, Rensselaer Polytechnic Institute, known as RPI, from
Okay.
New York. Stop by counseling to get a pass.
So was B okay, the maxes and mins?
College visits starting at 7:30
So
from
C?
Colorado Williams University, Oregon State, Dallas Baptist, Santa Clara.
What's the issue on 12? The graph, how to get it in the calculator? Is that what's the issue?
It says that there was
Please
one.
support the Jack and Boy soccer team. Bring your friends and drop in to each Chipotle near Wadsworth and 285 October 9th between 4 and 8 p.m. Remind the cashier of the fundraiser. Dad, make sure to come to the tailgate for food, games, and $6 at the bus seats on Friday before the game. Decorate your car from 5 to 5:30 at the
Yeah,
school
it
here,
said
and
mins
then
like
head to
that.
Trailblazer for the party from 6 to 7:30.
Oh.
Make sure to bring your own car paint.
Yeah, you should have
Drive, take the stand up.
2 points there, I think.
Will help start driving. Only 50 seats are available, so hurry to sign up.
So are we good on 12?
Drive. You will need to clear the
22?
parking lot today
Yeah,
at 3 p.m.
Good.
Please make arrangements to move your cars out of the west parking lot by 3 p.m. Thank you. Attention all female swimmers. There will be an interesting for this year's swim and dive team on Wednesday, October 9th at the Columbus. Sign up in your history teacher and then come to the meeting. The Dublin Junior High boosters are hosting their fall social this Friday from 2:30 to 4 at the cafeteria. Tickets are $5 and must be purchased during lunch on Thursday or Friday. Celebrate our Dublin Twins by attending the Twins Trivia Game in the auditorium today. Sign up for 7th hour normally and you will be released over the today at 1:55. Godlike Jack, congratulations to the lady volleyball players who succeeded at her great last week. Congrats to Sarah Hitchcock, Emily Demonte, and the Green Mountain Gymnastics team. They scored their highest team score of the season, competing against Arvada West and Columbine last night. Congrats to Emily, who tied for first place on beat. Softball wins again, beating Stanley Lake 11-0. Great job, ladies. Good luck Thursday for your homecoming game against number 1 of the state Golden. We need some fan support. Please come and show up. Also, only high school students are allowed to come to the toy game today. Have a great day, guys.
All right, I'm not sure what was the issue on 22. Why is that?
I shouldn't understand the domain.
Oh, okay, so you can't take the log of 0 or negative, so that means only positives for the top. Because you already said only positives, then this 0 is not an issue anyway, so it's just x greater than 0, all points greater than 0. Okay? Okay. Make sure I get 60-41 today. Have a lovely day. Who are you touring with? You haven't studied?
One of my friends.
I see that. Imagine.